So the reason that we reviewed geometric sequences and common ratios in the warm-up is because of what we're learning about today. Today we are going to basically apply what we've been learning, rational functions, rational equations. We're going to apply that to something that we learned way back at the beginning of the year, geometric sequences. Specifically, we're going to learn how to find the sum of terms of a geometric sequence. So in other words, if I have a geometric sequence and I want to know the sum of the first 30 terms of that geometric sequence, what is a way I can find that sum without actually having to add the first term plus the second term plus the third term, so on and so forth. And it turns out the formula we use, which is right here, the formula we use is a rational function. Okay, so this formula is really important. You're going to want to make sure you write this down in your notes. Not just the formula, but also what each of the variables stand for. What each of the variables stand for. There will be at least one question where you have to use this formula on the test on Thursday. So it's really important you have this written down in your notes. So this is the formula. A is our initial or our starting value. R is our common ratio. That's the number that, or the value that we're multiplying by each time. And N, okay, which is the exponent up here, N is the number of terms. So if I wanted to find the sum of the first 30 terms, like I said before, N would be 30, so on and so forth. So let's take a look at example number 1. Okay, Brandon is prescribed a course of antibiotics for an infection. He is told to take a 150 milligram dose of the antibiotic regularly every 12 hours for 15 days. He learns that only 5% of the medicine is still in his body after 12 hours. Based on this information, how much of the medicine will be in Brandon's body at the end of the 15 days? So, let's look at number 1 over here. Okay, so we are taking a 150 milligram dose every 12 hours for 15 days, and we know that there's 5% of that medicine left in the body after 12 hours. So here's our formula. Now, whenever I use a formula, whether I know the formula, whether I don't, I always like to identify what my variables are so I know what numbers to plug in for the different variables. So A, remember, or A value is the initial or the starting value. In this case, it's the medicine that he takes. In this case, that's going to be the 150 milligram dosage that he takes every 12 hours. So our initial value is the 150 milligrams. Okay. Our R value is the common ratio. Okay. And if you look down here at the bottom, when the common ratio is a percentage, the R value is the decimal form of the percentage, except in the following context. In the context being interest on investments or bank accounts. Now, this particular question has nothing to do with bank accounts or interest rates or any of that. So we're going to assume that the R value is the decimal form of the percentage. In this case, the decimal form of 5% is going to be 0.05. Okay, so our common ratio is a percentage, 5%. So the R value is going to be the decimal form of that 5%, which is 0.05. And lastly, N is the number of terms. In this case, the number of terms is going to be the number of doses of the medicine that Brandon takes. Now, what we want to be careful of here is Many of you may be inclined to say that N is 15 because he's taking the medicine for 15 days. However, the key in this case is that he's taking a dose every 12 hours for 15 days. So let's think about this here. We know that there's 24 hours in a day. If there's 24 hours in a day and you're taking a medicine every 12 hours, that means you're taking that medicine twice a day. Many of us, me included, will take medicines twice a day when we wake up and before we go to bed. So if I'm taking a medicine every 12 hours, that means I'm taking it twice a day. And if I'm taking it twice a day for 15 days, that means I'm taking a total of 30 doses of that medicine. So a 150 milligram pill, if I'm taking that twice a day for 15 days, that means I'm going to take 30 pills over that 15 days. So my A value is 150, my R value is 0.05, and my N value is 30. So now I can go right ahead and plug in those numbers. So 150 times 1 minus R to the power of N divided by 1 minus R. Okay. And you could just go right ahead and plug this into a calculator. I use Desmos. I did this up here before. All right, so I plugged that in, and this is my answer. So I'm going to go ahead and round that to 100. We'll go ahead and round that to 158 milligrams. So there will be 158 milligrams of medicine in his body after he takes his last dose, after he takes his 30th dose. So really, this was fairly straightforward. The only thing you want to be careful of is how often you're taking the medicine. If you're taking it every 12 hours, that's twice a day. If I was taking it, say, 4 times a day, okay, that would be 24 divided by 4, which would be, well, you guys could calculate that. Okay, so make sure you pay attention to how often you're taking the medicine. There will be an example just like this on your cool down tonight.